Okay, so from kilometer per hour to meter per second, you just need to multiply it by 5 by 18. And when you need to do the reverse, when you want to go from meter per second to kilometer per hour, you need to multiply by 18 by 5. Okay, so to save yourself from confusion, you might get confused where to go for 5 by 18 and where to go for 18 by 5. What you can do is you can remember it in this way, that when we were going from kilometer per hour to meter per second, from a bigger unit to a smaller unit, we were multiplying it with a fraction which is less than 1. Okay, and in the second case, when we were going from meter per second to kilometer per hour, we were going from a small unit to a bigger unit. So in that scenario, you need to divide it by the fraction which is more than 1. Okay, so if you have to divide it, multiply it with a fraction which is more than 1, so you'll have to go for 18 by 5. Okay, so you can remember it in this way to save yourself from the confusion. Again, I'm repeating, you just need to keep it in mind that when you're going from a bigger unit to a smaller unit, you multiply it with a fraction which is less than 1. So you will go for 5 by 18. And when you are going from a smaller unit to a bigger unit, from a smaller unit meter per second to a bigger unit kilometer per hour, you will multiply it with a fraction which is more than 1. So you will go for 18 by 5. Okay, this will work only from kilometer per hour to meter per second, not for any other units. Clear? Now the next concept is the concept of average speed. Okay, now you know that speed is equal to distance upon time. So average speed is equal to total distance upon total time. Okay, average speed is equal to total distance upon total time. Let's take a simple scenario. Let's say you covered 40 kilometers in 2 hours, then you covered 60 kilometers in 3 hours. You covered 40 kilometers in 2 hours, and then you covered 60 kilometers in 3 hours. And the question is to find out the average speed. So in this case, the total distance which you have covered is 40 plus 60, 100 kilometers, and the total time taken by you is 2 plus 3, 5 hours. So the average speed will be 100 divided by 5, which will give you 20 kilometers per hour. Okay, so 20 kilometers per hour will be your average speed in this case. Okay, if the distance is same, now a particular scenario on average speed which has been asked in a lot of aptitude tests, the scenario is when the distance is same. Okay, then what is the formula? We have a specific formula when the distance is same. If a car covers a certain distance at x kilometer per hour and an equal distance at y kilometers per hour, then the average speed of the whole journey is equal to 2xy upon x plus y. Okay, example, let's say you covered 40 kilometers at a speed of 20 kilometers per hour, and then you covered the next 40 kilometers at a speed of 30 kilometers per hour. Okay, you covered the first set of 40 kilometers at a speed of 20 kilometers per hour, and you covered the next set of 40 kilometers at a speed of 30 kilometers per hour. So in this case, the average speed will be 2 into 20 into 30 divided by 20 plus 30. Okay. Now, then comes the concept of relative speed. I believe you have read the concept of relative speed in physics. Going to college slowly and coming back with a high speed. Okay. Guys, we'll do the jokes later. We can always chat, but right now the internet is supporting us. So let's quickly focus on this. Okay. So now the concept of relative speed. If now if two people or objects are moving in same direction, with speeds of x kilometer per hour and y kilometer per hour, and let's say x is greater than y, then the relative speed would be x minus y. Okay, so whenever two bodies are moving in same direction, the relative speed is the difference of the two speeds. Okay, and when the two bodies are moving in opposite direction, so the relative speed is addition of the speeds. You simply need to remember it in this way: same direction, difference of the speeds will give you the relative speed. Opposite directions, speed addition of the speeds will give you the relative speed. Okay, so what is relative speed? It is the rate at which two moving bodies are separating from or coming closer to each other. A simple example to understand the concept of relative speed: if two persons are moving at 10 kilometers per hour and 20 kilometers per hour in opposite direction, then their relative speed will be 30 kilometers per hour, and the distance between them after 1 hour will basically increase by 30 kilometers. Okay, let's simply assume that you and your friend, you were standing at the same point and you started moving in opposite direction. Okay, let's say you moved at a speed of 10 kilometers per hour and your friend moved at a speed of 20 kilometers per hour. So after 1 hour, what will happen? You will cover 10 kilometers and your friend will cover 20 kilometers. And now, initially, there was no gap between you. You two were standing at the same point. But after 1 hour, the distance between you and your friend would be 30 kilometers, right? So this is what the concept of relative speed tells you, right? And just in case, imagine this was the scenario when you and your friend started moving in opposite direction. Now let's assume a scenario where you and your friend were moving in the same direction, started moving in the same direction. Okay, and initially you were at the same point. So you will cover 10 kilometers in 1 hour and your friend will cover 20 kilometers. So after 1 hour, you will have a gap of 10 kilometers between you and your friend, right? So uh, this the concept of relative speed is nothing but it tells us the rate at which the moving bodies are separating from each other or coming closer to each other. Okay, round, if we just want to round it up, we will say that when they're moving in same direction, take the difference. When they're moving in opposite direction, we will simply take the addition. Okay, now try to answer this question. So I've got 8 to 10 responses and all of them are saying yes. The answer is option B, yes. Okay, how did we find this out? According to the question, the runner is the runner completed a race of 750 meters in 2.5 minutes. Okay, now the distance is given in meters, the time is given in minutes, and the question is to find out if another runner who runs at 17.95 kilometers per hour, will he be able to beat another runner or not, right? So if we want to compare them, we will have to first of all find out the speed of the first runner in terms of kilometer per hour, right? And after we find the speed in kilometer per hour, only then we can compare their speeds, and then we can decide whether the first runner can beat the second runner or not. So when you convert 750 meters in 2 minutes and 30 seconds, that comes out to be 18 kilometer per hour. Okay, and the speed of the second runner is given as 17.95. Now, since the speed of the second runner is slightly less than the speed of the first runner, so the first runner can beat the second runner, will beat the second runner actually. Okay, next question for you guys. You can actually try to answer this without pen and paper. Yes, please everyone respond to the question. Okay, great. Thank you for your responses. The answer is option A. He decided to cover 2/3 of the distance, two-third of 6 kilometers. Now 2/3 of 6 kilometers will be nothing but 4 kilometers. So he decided to cover 4 kilometers at 4 kilometers per hour. So he must have taken 1 hour out there. 1 hour means 60 minutes. So out of the given 84 minutes, he has taken 60 minutes. So now he is left with 24 minutes and he is left with a distance of 2 kilometers. So now he wants to complete 2 kilometers at a speed of 2 kilometers in 24 minutes, right? So that comes out to be 5 kilometers per hour. And most of the people out here, they answered 4 kilometers per hour. Okay. So are you guys able to identify your mistake? Please read the question once again. A man decided to cover a distance of 6 kilometers in 84 minutes. So this was his total plan, where he decided to cover two-third of 6 kilometers, which is 4 kilometers, 4 kilometers at 4 kilometers per hour. So it means to cover this 4 kilometers, he has taken 60 minutes. So out of his total plan, now he is left with 2 kilometers and he is left with 24 minutes. So the question was to find the speed after the two-third distance has been covered. So you need to find the speed where he will cover 2 kilometers in 24 minutes, right? So have you identified your mistake? Yeah, Shivam, the answer will be 5. Now, see, the reason why you guys did it wrong is because as soon as you calculated something where 4 came out, that was there in the first option. So you didn't bother to check what was the question, right? And this happens in a lot of aptitude tests. In fact, when I frame a paper, what I do is I look out for the common mistake in that particular question. And by doing that common mistake, let's say someone is getting 5, okay? So I always put the very first option as 5 to make sure that the person is marking that, okay? This is just to make sure that the person is careful with the steps, okay? Okay, so now train problem. Guys, generally you will see a lot of questions in time, speed and distance involving trains, okay? So I have covered, like, ultimately there are 4 or 5 particular scenarios which you need to keep it in mind. Okay. Now, let's say I have made the cases L1 be the speed of first train, L2 be the speed of second train, S1 and S2 be the speed of first train and second train respectively, and SM be the speed of man. Okay. Now let's just try to understand the scenario. If you are standing, on a platform, okay, if you are standing on a railway platform and a train is coming, then what is the time taken by the train to cross you? Okay, what is the time taken by the train to cross you? Now when you get this question, what is the time that you need to find out? You need to find out the time, when the time starts when the first coach of the train just crosses you. At that instance, the time starts, and when the last coach of the train crosses you completely, then the time ends. Okay. The time starts when the engine or the first coach of the train just crosses you, and the time ends when the last coach of the train has crossed you completely. Okay. Now this entire duration is the time taken by the train to cross you. Okay. Now just try to imagine what has happened in that time duration. In that time duration, actually the train has covered its own length. Okay. Your length is negligible as compared to the length of the train. So in that duration, the train has actually covered its own length. And since you were stationary, since you were not moving, so the train has covered its own length with its own speed. Okay. And so L1 divided by S1, length of the first train divided by the speed of the first train, will give the time taken by the first train to cross you. Okay. So is this part clear? Because only then I can proceed further. And this is completely conceptual. If you understand these 5 points, then you can answer any question of train. Okay. So now, if you get if I simply ask you that there is a Shatabdi Express of length 200 meters, there's Shatabdi Express of length 200 meters. Okay. You are standing on the platform. The train is moving at a speed of, let's say, 10 meter per second. Shatabdi Express is moving at a speed of 10 meter per second, and it has you are standing on the platform. So the question is to find out the time taken by the train to cross you. Okay. Time taken by the train to cross you. Now you need to use this concept of train crossing a man. If you remember the formula, well and good. But if you don't remember the formula, just try to understand that scenario. That if you are standing on a platform and the train has Shatabdi Express is crossing you. So what will be the time taken by the train to cross you? Now during that duration, since you are not moving, so only the speed of the train will be considered. And with that speed, what is the distance covered by the train in crossing you? You need to imagine that. When the first engine or the first coach of the train has just crossed you, at that point, the timer starts. And as soon as the last coach of the train has completely crossed you, the timer stops. And in this duration is nothing but the duration taken by the train to cross you completely, right? Clear? This is the time taken by the train to cross you completely. So now is it clear, Khushbu? And what will be the answer? 200-meter train moving at a speed of 10 seconds. So it will be 200 by 10, 20 meter per, 20 seconds. Okay. So I hope this is clear. Now let's move ahead. Let's try to imagine that you were not stationary. You were also moving. Okay. And now I want to find out the same train, the time taken by the same train to cross you. Now guys, try to understand the scenario. Now since you are not stationary, you are going to move. So now this concept of relative speed will come into play. In the initial scenario where you were stationary, we were not taking relative speed. We were only taking the speed of the train. Okay. But now in this scenario, if you were also moving, let's say you were moving in the direction of the train or in the direction opposite to the train. In this case, the concept of relative speed will come into play. And now to find out the time taken by the train to cross you, time is equal to distance upon speed, right? So in this case also, the time taken by the train will be equal to the length of the train divided by the relative speed. So now in the denominator, the relative speed is what you need to calculate. Okay, you will have to calculate the relative speed. The relative speed will come in the denominator, and then you will be able to find out the answer for the time taken by a train to cross a moving object. So is the second scenario clear now, guys? Is the second scenario clear? What will be your approach to find the time taken by a train to cross a moving object? Okay, great. Thank you. So now we have taken two scenarios. First, where you were stationary. Okay. Second, where you were also moving. Okay. Now let's imagine the third scenario where we want to find out the time taken by the train in crossing a stationary train or a platform. A stationary train or a platform. So now you need to just imagine that you need to find out the time taken by the train to cross the platform on which you were standing. The time taken by the train to cross the platform on which you were standing. Now, my very first question for you guys would be the time taken by the train to cross the platform on which you were standing and the time taken by the train to cross you. Will the two times be equal? Will the two times be equal? My question is, let's say the time taken by the train to cross you is X seconds. So the time taken by the train to cross the platform on which you are standing, will it also be X seconds? No, right? Why no? Why no? Now tell me why no? What will come into play here? Exactly. Now the length of the platform is quite large as compared to your length, right? Your length will be negligible as compared to the length of the platform. Yes or no? Your length will be negligible as compared to the length of the platform. So now, if I want to find out the time taken by the train to cross the platform, so just imagine how will the timer act now. The timer will start. The timer will start when the timer will start when the first engine of the train has just entered the platform. The timer will start when the first engine of the train has just entered the platform. and the timer will stop when the last engine has completely crossed the platform or has completely came out of the platform. Okay, so now in this entire duration, the train has covered its own length for sure, plus it has also covered the length of the platform, right? In this timer, the train has covered its own length, plus it has also covered the length of the platform. So now in this duration, we will have to consider two different lengths. Okay, and that is why you can see that in the third formula, in the third scenario, the time taken is equal to L1 plus L2 divided by S1, where L1 is length of, let's say, the first train, and L2 is the length of the second train or length of the platform, whatever the second object, which is quite huge. Okay, so this is what your approach would be to find the time taken by the train to cross an object whose length is considerable with respect to the length of the train. Okay, now you cannot ignore the length of that object with respect to the length of the moving train. So please, I would like to know your responses. Now, is the third part clear? Is the formula clear? How we got this L1 plus L2 divided by S2? Okay, thank you for your responses. So now just imagine the fourth scenario. What is the fourth scenario? Train crossing another train. Okay, now in the third scenario, I have taken train crossing a platform, right? Now imagine that the train was crossing another train. You must have like observed, if you have done train journey in your life history, that if there is a train which is coming in from the opposite direction, the two trains, they cross each other very quickly, right? But when the two trains are moving in the same direction, it actually feels like you can jump in the second train. So what happens in that scenario? In that scenario, the time taken by the train to cross another train is actually equal to length of the two object, length of the two trains divided by relative speed, okay? So basically the thing which you need to keep in mind is, since in all these scenarios, we are focused on finding out the time, and time is equal to distance upon speed. So you will have to keep in mind that if the second object is moving, so in the denominator, the speed will be the relative speed. But if the second object is not moving, so the speed in the denominator will be the normal speed of the object. Okay, and in the numerator, whenever you have to put the value of the distance, you will have to think that you will consider the length of the object moving, plus you will consider the length of the other object if it is considerably large with respect to the length of the train. Okay, so in this way you need to keep it in mind. And lastly, the fifth scenario is where we have to find out the time taken by the train crossing a man in a moving train. Okay, so now the last scenario is, let's say you are sitting in Rajdhani train, and there's Shatabdi crossing you. Okay, there's Shatabdi train crossing you. So now the question is to find out the time taken by the train to cross you. Okay, try to imagine the scenario. You are sitting in a Rajdhani train. Now a Shatabdi train, it might be moving in the same direction or it might be moving in the opposite direction. It does not matter. We are just concerned with finding out the time taken by the Shatabdi train to cross you. Okay, to cross you. Now, if you try to imagine that scenario, in that time, the in that duration, the length covered by the Shatabdi train will actually be the length of the Shatabdi train itself, right? Yes or no? Are you able to understand the last scenario? So, in the last case, the time taken by the Shatabdi train to cross you will be equal to the length of the Shatabdi train divided by the relative speed of the two trains. Because your train is also moving, Shatabdi train is also moving, and since there are two objects moving, so we will have to consider the relative speed. Okay. So, are all these five cases clear? Ashutosh has asked a big question. What if two trains are running in opposite direction and a man is inside a train? The speed of train in which there is a man inside has speed of x. So, Ashutosh, in this case, what you will do is you will consider all the three relative speed. Okay, you will consider all the three relative speed. Let's say if you were not sitting, you were moving in the direction of the train. You were moving in the direction of the train. So in that case, you'll consider the relative speed. That's all. Okay. In that case, all the three speeds will be calculated. Shivam, in the fourth formula and fifth formula, maybe it will be S1 plus minus S2. Yes. See, basically, if the relative speed, if the two objects are moving in opposite direction, it will be S1 plus S2. Yes, it will not be SM, guys. It will be okay. Yes, yes, Ashutosh, it will be L1 by Z plus X minus 1. Okay, so guys, these are the five different scenarios which comes in train problems. You will not get a single case apart from these five. Okay, so now let's try to solve some questions. 30 seconds, hurry up. So people are confused between option A and option C. Okay, let's look into the solution. The answer is option is seconds. The length of the train is given as 100 meters, which we can convert it as 0.1 kilometer. And the speed of the train is given as 60 kilometers per hour, right? So length is given, speed is given, time is what we need to find out. That will be distance upon speed. So 0.1 divided by 60. 0.1 divided by 60 That will come in fraction. When you multiply it with 3600 to convert it in seconds, you get the answer as 6 seconds. Okay, simple question. So here's the next question for you. How long does a train 100 meters long moving at a speed of 90 kilometers per hour would take to pass through a 500-meter long bridge? I have not given the options so that people, they don't guess, they tell the exact answer which they're getting. Just check it once again, Abhishek. Anaga, please check it once again. Shivam, check your answer. Sam, check your answer. Yes, Khushbu, it's 60 seconds. Guys, the answer is 60 seconds. Now, the very first thing, listen, the speed is 90 kilometers per hour, right? Speed is 90 kilometers per hour, but the length given is in meters. So what we can do is we can try to convert the speed into meter per second. Now, if I want to convert kilometers per hour to meter per second, we are going from a bigger unit to a smaller unit. So we will divide it by a fraction which is less than 1. So we will go for 5 by 18. Now, when we go for 5 by 18, 90 is completely divisible by 18. So you get a 5. And 5 into 5 will give you 25. So here we get the speed as 25 meter per second. And now since the length of the train and length of the bridge, we need to consider both the length. So the total distance will be 1500. And this 1500 will be divided by the speed, which is 25 meter per second. So 1500 meters divided by 25 meter per second. When you divide 1500 by 25, you get a 60 there. And the unit will be second. Okay, so you have to be a little bit careful for this particular question. The answer will be 60 seconds. The options could have been 60 hours, it could have been 60 minutes, and people might go for that as well. Okay, but please keep it in mind while solving the questions of time, speed, and distance. Please keep a check on the units before you mark the correct final answer. Okay. Okay, guys, there's a small question. What do you suggest to go for, either meter per second or kilometer per hour? Now, since in this particular scenario, I have not given you the option, so you can go for either of those. Okay. Now, since speed was given as 90 kilometers per hour, and this was when you convert it to meter per second, it becomes an integer. So I prefer to go for that, because if we go for 1000 meters and 500 meters to kilometer, you will get a fraction. Okay, the fraction is very easy, 1.5. But since I'm going to get a fraction, so I try to avoid that. During calculation, even we know that everyone is more comfortable in dealing with natural numbers, whole numbers, and integers. As soon as we get fractions or decimals, our speed decreases by some seconds, right? So always you should decide what will be the easier approach. Okay, it is not confined, there's not a particular way to solve a question. According to the question or according to the options, you will have to keep on modifying, but always try to go for that calculation where you come across integers. Okay, if you don't have any other choice, you need to go to, and then you go for that. But if you have an option where you can convert the new numbers to fraction or integers, always go for integers. Okay. So the answer is 1 minute, 60 seconds. Okay. Next question. Now try solving this question without pen and paper. Everyone, try without pen and paper.